I would like you to observe an important property of a probability distribution. I prepared two probability distribution tables. The first one is for a fair die. If I roll a six-sided normal fair die, the probabilities are equally distributed, so the probability of getting one of the results is always 1/6. The one below is the probability distribution for an unfair die. So someone filed the die down to make it unfair in such a way that the probability of getting a 6 is way higher than the rest of the results. And but what is in common here is that if I add all of these probabilities, right? If I add the probabilities, let's look at the first table. So I'm finding the probability that I will get the result 1 or the result 2 or 3 or 4 or 5 or 6. So naturally, I'm basically finding the probability right now that I will get one of those, which has to be equal to 1. Because, well, if I roll a die, I have to get 1 or 2 or 3 or 4 or 5 or 6, naturally. So then I get an event which has to happen, and then the probability is 1. And the same will happen in any probability distribution. If you just add all of the probabilities, the result is 1. So that's the observation that we have to remember here. If you add the probabilities for all x's, for all the values, then the result is 1. And in this formula I used the notation for probability from the first table. I could also use the second notation, simply p of x, and then I can just write that the sum for all x for the probabilities is 1. Either way, the point is that if you add all the probabilities together, you will get 1. Let's take a look at an example. Here we have an example. The tetrahedral die has the numbers 1, 2, 3, 4 on its faces. The die is biased in such a way that the probability of the die landing on any number is k over x, where k is a constant. Find the probability distribution for x. The random variable is the number that the die lands on after a single roll. Okay, so I have a weird die here. That's okay, it's just a tetrahedral die, which means that I have 4 faces. That's okay. 1, 2, 3, 4. That's the only result I could get. And I would like to find the probability distribution, so my distribution table, right? So let's draw up a table. And the only values that the random variable can be are 1, 2, 3, and 4. And the probability that the random variable is x is. Okay, this is a biased die. It is a biased die. Where is this word? Let's underline biased. It means that it won't be equally distributed. It's a cheating die. So it won't be quarter, quarter, quarter. But we have a recipe for the probabilities here in the exercise. It's k over x. So the probability of getting a 1 is k over x, where x is the value, so x is 1. The probability to get a 2 is k over 2, k over 3 is for 3, for 4 is k over 4. So these are my probabilities. But if I'm asked to find the probability distribution, I need to find them. So I need my k. I need to know what k is. So let's use the formula. Let me just grab this formula here. The formula was that if I add all these probabilities for all the values of x, I will get 1. I will get 1. Okay, so let's do it. I will take all of these probabilities. If I add them, the result has to be 1. The probability of getting 1 or 2 or 3 or 4 is 1. So let's write it down. K over 1 plus k over 2 plus k over 3 plus k over 4 plus k over... oh, that's it. K over 4 is the last one, is 1. And let's solve this equation. I will multiply everything by 12 to get rid of the fractions, to make my equation easier to solve. And then I have 12, 18, 22, 25, k is 12. That means that k is 12 over 25. So now I can substitute 12 over 25 for k in my table, and in this way I will prepare a probability distribution. Okay, let's do it then. Okay, we need a little bit more space, so I will just scroll, and now let's prepare a new table with the probabilities. So the probability that it landed on 1 is k over 1, so simply 12 over 25. I know that k is 12 over 25. 2 was k over 2. 12 over 25 over 2 is 6 over 25. 3 was k over 3, so 12 over 25 over 3 is 4 over 25. And 4 is k over 4, so 12 over 25 divided by 4 is 3 over 25. That's it. That's the probability distribution. That's my solution. To remember is this formula. If I add all the probabilities together in a probability distribution table, I get 1.